Hello, this is Dr. Hisham Saeed. In this video, we'll learn about construction operation modeling. So how to look and model and a construction operation so we'll be able to analyze it later and optimize it. Uh, so, um, so we'll learn here about the importance of designing construction to efficiently use its resources, and then model the operation using activity cycle diagram. So in a previous lesson, we mentioned that a construction operation has three main inputs: the material that's being used in this operation and the labor and equipment that are working together to transform this material. A project manager and project engineer need to make sure that these resources are used efficiently and coordinated well to achieve an efficient construction process. This is done by making decisions that are strategic and tactical. So strategically, they need to decide on what's the appropriate technology or construction technique to use for this operation. While tactical decisions can be made during the decision and over kind of ongoing process to optimize and improve the process. So the lack of operation design here, designing the operation, meaning that how many resources to use, how they are utilized. Lack of this will lead to low efficiency. So when designing an operation, what is the main metric that we are trying to consider here? So as most of the construction industry is driven by cost, so we're considering here the unit cost, how much it will cost to do one unit of work, considering the usage of that crew and its composition and design. So unit cost here is equal to the crew hourly cost divided by the crew hourly production. And just by laying here the units of each one of these variables, you can see that the unit cost dollar per cubic yards, for example, would equal to dollar per hour divided by cubic yards per hour. So this means to have an efficient operation, we'll have to, this will be translated into having the least possible unit cost, which can be achieved by two things: using a minimal size crew that's efficiently designed and well coordinated to result in the maximum production. So to design an operation, to design something, you have to model it and you have to analyze it. So the tool to analyze operations in general, it's not only in construction. There are many tools, but one of the famous tools is activity cycle diagram. So activity cycle diagram is it's a diagram. It's a network of activities and resources that are drawn and represented to represent discrete event-based operation or process. So this is the process. First, you have to look at what are the resources involved in this operation. Next, you will have to define for each resource the cycle. You have to track and trace the path of this resource and see where exactly it goes, what tasks it does. And then once you identify the individual cycles of every resource, then you try to see where they actually overlap, where these resources come together to do something and then depart to do the rest of their own cycles. And at the end, you verify the diagram, make sure it makes sense, and write on the diagram any logic statements that you would like to represent. And so to clarify here that the logic is represented well to mimic what's really happening in reality as much as you can. So let's do kind of explain or show the application of ACD, activity cycle diagram, using this example here. So we'll run here this video of a hauling operation, what we call cut to fill operation. So we have a truck or a bunch of trucks moving or hauling the soil, and they are being loaded by an excavator. So let's watch here and see what's the process here, so we can model it using ACD. So the truck is coming from its previous trip. It's coming from the fill section, or the fill area, or the backfill area, and it's kind of driving into the spot where it will be loaded by the excavator. You can see here that the excavator was sitting idle waiting for a truck to come. So that's something we can pay attention to. And it's kind of an inefficiency, right? So an equipment is being paid by hour, and then it's waiting for another resource, another equipment to come for a couple of minutes. Over time, these couple of minutes will translate into hours, and then you're actually losing money here. So now it's being like, the excavator is kind of doing its own cycle, little cycle of filling the bucket, swinging, and filling the truck. But that's little kind of cycle here. So let's keep going like that. Let's see if I can run here. So it's still loading. I think this is the last bucket, maybe. I bet you this is the last one. No? Oh, wow. Okay, keep going. That should be the last one. There you go. Did you hear the horn? So this is the second horn, so this means that the excavator is telling the truck to move. There you go. So the truck is moving now from the cut area, and you can see it's a little struggling with this load driving uphill. And now it's arrived. We just got through the driving part, so it's arrived at the fill area. This is where it will dump the soil and go back to the excavator to be filled. I'll also run through that quickly. So see how heavy it is, like struggling to carry that load, and it's driving backing up to this filling pit here, where you can see there is some compactor here on the back, compacting the soil being delivered. And by the way, this truck here is called articulated truck. So you can see the cabin is kind of swinging in a different angle than the box of the truck itself. Now this is a dozer waiting for the load so it can spread it and provide initial compaction to the soil, and then the compactor will come and compact the soil. And then it goes on. Now it's empty. It goes to repeat the process, or what we call the cycle here. Okay. So by looking at the video, I'm sure you've seen two main resources here. If you think only about hauling, so we're not considering the compaction part, because the compaction is done by the dozer, the spreading task, and also the compaction by the roller. But here we're only thinking about the hauling process, digging and hauling and then dumping, and that's it. So here there are two resources, the truck and the excavator. We draw here mainly two symbols. The circle is for kind of what we call a queue, is where any part of the cycle, the process, the resource would be waiting for another resource to do a task. So the truck is being loaded by the excavator. So we're currently thinking it as kind of segregated two processes. Because we're thinking initially this way, we focus on the resources, their own cycles, and then the next step would be to kind of combine these cycles where they should be combined. So truck is loaded, truck travels, truck dumps, and then truck returns to wait for the excavator so they can do that loading process. So two cycles. Now the next would be now combining these two cycles where they meet, which is loading the truck. So I have here 4 tasks and 1 queue representing each one of these two resources. And then I can actually expand my cycle diagram by adding details to it that I skipped it in the beginning. So in here, I added here drive in spot and maneuver, kind of adding that little time that the truck drives in spot for dumping, and then maneuvering, driving, and then coming back to be loaded by the truck. Kind of providing more detail and more representation of what's really happening there. I also kind of model the bucket cycle of the excavator, but that's maybe something that it's up to you as a modeler or as the person who's analyzing the process to decide on the level of detail you want to go to. One thing also I added is tracing the material that's being used in this process or operation. So I added here a queue, that circle here where the soil need to be cut at the cut area, and it joins the load here and kind of join in one arrow now, representing this is a loaded truck and this is empty truck joining the soil, and then becomes a loaded truck. And then the excavator here has its own arrow and cycle. So loaded truck, loaded truck, loaded truck, and then empty truck, and then the dumped soil here. So I can detail more and more, but this is kind of, let's say this is sufficient level of detail or expansion of the activity cycle diagram. And then I can detail it or annotate it now by adding the times that I have observed while watching the video or observing the process in reality. So kind of the times, assuming that this is what I observed. And also I can notice here that I can annotate the number of resources or the number of instances, they call it, or number of units of each resource I have. So for trucks I have 4, and excavator I have 1. It's just an example, it's one possible group. And also I can put the units of the material that's being used or going through the process that I have. So that's a very quick example of implementing and using activity cycle diagram. Now let's see a more advanced example with more interesting cycles here and dynamics. So this is a concrete placement using crane and bucket. So tower cranes and then buckets, like kind of they're working together here. The bucket is always attached to the crane. The crane is swings and goes to the truck, which is the ready mix concrete truck. It gets loaded and then it swings to the building where this is what we call the elephant trunk. So the concrete is here and then it flows to the form of the column. And we're analyzing here the placement of the concrete into the columns. What we see here is the bucket has a 8 cubic yard capacity. Concrete was delivered in trucks with capacity of 8 cubic yards also, so the same capacity as the bucket. But each column here has 1 cubic yard volume. And then you have the placement of the concrete is done by construction workers and electric emergent type of vibrator. So these sticks kind of they put in the concrete to vibrate it and condense it, make sure it's well condensed into the form. So if you kind of visualize, you can YouTube and look for kind of the crane and bucket operation of pouring and placing concrete. But if I tell you a story through the ACD, now we have trucks, the crane, and the crew, placement crew, are the three main resources. So the operation starts here by the truck waiting for the crane to load the bucket. Once this loading process or task is done, then the truck goes into its cycle. So when you say here trucks, transit here means the time that the truck is in transit outside of the site. So transit includes traveling to the batch plant where the concrete is being prepared, being loaded in the batch plant, and then returning to the site. Three things here: travel, load in batch plant, and returning. This is collectively here as the transit time or transit task. Once it comes back, it waits for the crane to be available to load the bucket. So once the bucket is loaded, then the crane hoists the bucket to the top of the building. Once it's the bucket is hoisted, now this can be, we're tracking now the cubic yards of concrete. So that translated into 8 cubic yards of concrete. Now each one of these 8 cubic yards of concrete is used to build a column or make up a column. The column is placed, the concrete of the column is placed and vibrated by having 1 cubic yard of concrete and the placement crew available. Then moving here to once the column is done, you move to the next column. So you move to the next column, the crew is moving, and then once it's there, it's idle, waiting for availability of concrete. So, but once you place a concrete in a column, then you kind of record or track that you've done 1 concrete of placing work here. And you keep doing that until you start here with 8 cubic yards, you take 1 by 1, so you do 8 columns. Once you don't have anything here, the crew gets into the crew waiting area or queue and stays there waiting for the next bucket to come. So the next bucket will come when now I have here 8 cubic yards, right? Because I start with 8, I took 1 by 1, I ended up with 8 cubic yards here. And now this is here the placement crew, but here I should have now 8 cubic yards. Once I have all of them, I can pull all of them and do the activity of return bucket. So the numbers on the arrows here kind of represent when this arrow can be kind of executed, if you think about it as programming in some way. So once I have 8 cubic yards here, I can pull all of them at once, and then the bucket this means the bucket can return now. So the bucket will return, and then return to the spot where actually it will be loaded. Now, if I have a truck available, the bucket is available, I will load, and now I will repeat the crane bucket cycle. So now I have 3 resources: trucks, crane, or bucket combination, and then crews. And you can see here visually the cycle of each one of these 3 resources. So pretty cool, right? So ACD kind of helps to visualize the operation, so you can, what we'll see in next videos, how to analyze it by numbers, cycle time, proactivity, the crew proactivity, and all of that stuff we'll learn in the next video. Thank you and take care.